Hello, this is Justin with Green Residential. In this video, we're going to talk about attic ventilation. Let's get started. So attic ventilation is important for many reasons. One is the temperature in your house. So if you've ever gone to an upstairs bedroom in the summer and you've noticed that it's really hot in there, and if you've gone closer to the ceiling, that heat just increases a lot more, well, there could be a possibility that that is due to poor attic ventilation. So in your attic, you have incredibly hot temperatures in the summer. It's really important to be able to remove that hot air that builds up in the attic. If you don't have an adequate ventilation system, that heat will radiate into the house, which in turn causes your AC to work extra hard, which means higher electric bills, and it also shortens the lifespan of the AC just because it's having to work so hard. Another thing that it's bad for is the shingles on your roof, so that high temperature in the attic can actually damage your shingles. Another downside of poor attic ventilation is you can potentially also get moisture buildup in your attic. So good ventilation will remove that moisture to prevent any moisture buildup, which can cause mold and even structural damage to the actual framing members of the house. So attic ventilation is a really important thing. It's many times overlooked. So there's different types of attic ventilation systems. A common one that we see nowadays is you'll have an opening at the soffit. Sometimes it will just be tiny little holes all along the soffit, or it will be an opening with a screen. That allows cool air to be pulled in at the lower part of the attic, and then at the top part of the attic, there'll either be some sort of vent, like a turbine vent or a turtle vent, or a ridge vent that allows that hot air to escape. Another type of attic ventilation system that you'll see on older houses is gable vents. So there'll be an opening at the top part of the gable of the house. This will be placed on either side of the house, which will allow for a cross ventilation of the attic. Building code weighs in on this. This is the 2024 International Residential Building Code. This is Chapter 8. In here, it talks about the requirements of roof ventilation. So here's a few key concepts that code requires. It talks about enclosed attics and enclosed rafter spaces formed where the ceiling is applied directly to the underside of the roof rafters. They need to have cross ventilation. It also sets forth the minimum opening. Ventilation openings shall have a least dimension of 1/16 of an inch minimum and 1/4 inch maximum. If you have an opening larger than that, you need to apply a screen of some sort that complies with code. It also sets forth that at least a 1-inch space shall be provided between the insulation and the roof sheathing at the location of the vent. You can install an insulation baffle that will keep the insulation away from that 1-inch area to allow airflow. So this is important. The minimum net free ventilating area shall be 1 foot for 150 feet of the area of the vented space. So for every 150 square feet, you need 1 square foot of ventilation. Now, there are some exceptions. The minimum net free ventilation area shall be 1 in 300 square feet of the vented space, provided both of the following conditions are met. 1, in climate zones 6, 7, and 8, a class 1 or 2 vapor retarder is installed on the warm in winter side of the ceiling. And number 2, not less than 40%, not more than 50% of the required ventilating area is provided by ventilators located on the upper portion of the attic rafter space. Upper ventilators shall be located not more than 3 feet below the ridge highest point of the space measured vertically. The balance of the required ventilation provided shall be located in the bottom 1/3 of the attic space. So you have a situation where it's roughly split 50-50. 50% of the vents are placed near the soffit where air comes in, and the other 50% are roughly placed near the ridge where air can escape. There's more to this. I'll place a link to the ICC website in the description of this video, and that way you can check it out. Now, it is possible to overventilate your attic, so it's really important to follow these stipulations, whether it's 1 to 150 or 1 to 300. Overventilating your attic will actually start pulling cooled air or heated air from the interior part of your house and moving it into the attic. It will be through any little opening in the drywall. So if you have a ceiling fan or a light fixture, any little opening between that and the electrical box where that light fixture or ceiling fan attaches, or an AC register, you potentially then have a situation where warm air and cold air are mixing, which also could potentially form a dew point, which can create moisture. That moisture can be a source for mold and can damage any surface that it's touching. This actually creates a case for creating an airtight barrier between the interior living space and the attic. Even ice damming that you see in wintertime in northern places is a result many times of poor attic ventilation. So hot, humid air that comes from the inside of the house sitting in the attic, so it begins to melt the snow on the roof, but as it moves further down, the soffit part, so that is colder, or the porch or whatever it is, as it sits outside the thermal envelope, so it freezes up again and you create this dam. So the real solution is having the full length of the roof the same temperature in the attic. This goes back to creating an airtight barrier between the living space and the attic. Well, I hope this video was helpful. If you found it helpful, it'd be much appreciated if you hit that thumbs up button. You know, we put out videos like this on a regular basis. They include simple repairs that many homeowners can do, and they also include house knowledge like this. I'm so glad you caught this video. I hope you catch my next one. Have a great day, and bye for now.